Okay, welcome back, friends. So let us continue with where we left, and we had already discussed the composition of the atmosphere. I think. Ek minute, just let me open the file. So we were discussing about the composition of the atmosphere, and we also talked about the another category of variable gases जो हमने कल नहीं बात किया था. So that is the another category of variable gases. Yesterday, if I remember correctly, we discussed till ozone. So the next category of variable gases, if you talk about, is the polluting gases or the pollution which is present in the atmosphere. Okay. So if we talk about the pollutants, essentially they are of two types. One is what we call them as the primary pollutants, and then there is the secondary pollutants. Okay. So it is very common to find in the atmosphere other variable component which we use is the pollutants. So there are two types: primary pollutants and the secondary pollutants. So these primary pollutants are various if you talk about the reactive components. Reactive components which are present in the atmosphere. And if we talk about these reactive components, you can see two most important reactive components are the sulfur oxides which are present and the nitrogen oxides. Beside there is also volatile organics, and there is a very important pollutant, primary pollutant, that is carbon monoxide. So you draw this pie chart. So most important among the pollutants is the carbon monoxide, almost 49%. Then there is nitrogen oxide, which is 14.8%. Then there is volatile organics. Volatile organics is around 13.6%. Sulfur oxides, that is 16.4%. And then there is particulate, or what we call it as the PM particles. And you know PM10 and PM2.5 suna hoga. So particulate matter, that is around 6%. Okay. So this is percentage by weight of the overall the pollutants which are present in the atmosphere. I have told you before also, I think. What do you understand by the term pollutants? Pollutants are those substances which are introduced in the environment which have harmful effect and are not naturally found in the concentration to be harmful. So such type of substances are referred to as the pollutants. So very clearly, this is much of it. If you talk about is what it is human made scenario. So humans have added these into the atmosphere. So number of sources are there. Of these, one is the basically the combustion of the fossil fuels. That is one of the primary factors. In fact, if we look into the causes of these primary pollutants, you can see the biggest single cause is the transportation sector. Okay. So biggest single cost comes from the transportation sector. Almost 46% of the total is coming from the transportation sector. Then second important is the stationary fuel combustion, which is around 27%. Around 27%. Industrial processes, they account for around 15%. Solid waste disposal is around 2.5%. Then there are miscellaneous sources as well. Like agriculture is one of the sources, miscellaneous sources. Okay. So if you remember, we had seen yesterday the syllabus of climatology. Okay. And in the syllabus of climatology, we saw there was one topic, urban climates. देखा था? So can I say this, for these pollutants, will they be most manifested in the urban climates? Very clearly, they will be most manifested in the urban climates. There is another topic in our syllabus, that is the impact of human beings on the environment and ecology. This topic is mentioned in the environmental geography. That is the fifth topic of physical geography. ठीक है? So what I'm just trying to say, tell you is, कई बार क्या होता है कि we are always looking for a ready-made material. ठीक है? सो दैट इज वन वे ऑफ प्रिपरेशन कि हर टॉपिक का एक रेडीमेड मटेरियल मेरे पास एकदम रेडी है, पूरा आई हैव गॉट एवरीथिंग. बट टेल मी, अगर मैं हर टॉपिक का सेपरेटली पूरा डिटेल में रेडीमेड मटेरियल बनाऊंगा, तो विल माय कंटेंट बिकम वेरी बल्की? इट वुड बिकम बल्की. आई विल हैव टू पुट ऑल्सो लॉट्स ऑफ एफर्ट्स. ठीक है? सो कैन आई से वन स्मार्ट वे विल बी कि जो हम कहीं पर पढ़ रहे हैं, इफ इट कैन बी अप्लाइड इन अदर टॉपिक्स, if it can be used in other topics, should it be done? Definitely it is the case. So throughout we will see, we will keep on applying here and there, interconnecting the topics, and जो हमने उधर पढ़ा है उसको हम इधर लेके आएंगे, जो इधर पढ़ा है उसको उधर लेकर के जाएंगे. So likewise we will be doing, and that is the most smartest way to prepare. So that is basically the composition of the atmosphere. So moving on to our next topic, the basic topic of structure of the atmosphere. Structure of the atmosphere. So when we are talking about the structure of the atmosphere, in many ways we can do the structuring of the atmosphere. Structure here, when we are saying, we are in a way trying to classify the atmosphere. Okay. So there can be various bases on which we can talk about the structure of the atmosphere. One can be on the basis of composition. On the basis of composition. So on the basis of composition, do you remember we talked about that the atmosphere up to the height of 80 kilometer, it was homosphere. It was essentially homosphere. Above this is your heterosphere. And in heterosphere, according to the molecular weight of the gases are essentially arranged. Okay? So here what we will be finding, here there is layers in which the gases are arranged. There is nitrogen, there is oxygen, there is helium, then there is hydrogen. There is hydrogen. This is, if you talk about, this boundary is somewhere around 550 के आसपास होता है, किलोमीटर के आसपास. If you talk about this boundary, it is somewhere around 1100 something kilometers. And if you talk about this is around 2300 kilometers के आसपास होता है. So this is the division of the heterosphere. Heterosphere. And as I told you, here the gases are arranged according to their molecular weight. ठीक है, एक और बाद में भी देखेंगे. इनफैक्ट हियर लाइक ऑक्सीजन की अगर हम बात करें तो नॉर्मली अगर हम नीचे देखेंगे तो इट इज फाउंड इन द फॉर्म ऑफ व्हाट, एज इन मोलिकुलर फॉर्म. हियर वी विल सी दैट ऑक्सीजन विल बी फाउंड मोर इन एटॉमिक फॉर्म. ठीक है, देयर इज प्रेजेंस ऑफ एटॉमिक ऑक्सीजन. So that is one on the basis of composition. Here we are classifying the atmosphere. There can be classification of atmosphere even on the basis of atmospheric pressure. Atmospheric pressure. So just give me 1 minute. All this I will show you later on when we'll move on. So see, what is happening here? Can you see? As one goes up, what is happening to the atmospheric density? It is declining. Okay? So the density of air declines with rise of air. So at the sea level, what we find, what is the average sea level atmospheric pressure? It is around 14.7 pound per square inches. We measure it in millibars and it is around 1013 millibars. Okay? So this is the average sea level pressure which is found. But what happens with altitude? We find that with altitude the pressure keeps on declining. So for example, at the sea level it is 1013, but at 1 kilometer it has just become around 900. If you look into at 5 kilometer it is 540. By, can you see, 40 kilometers, we are far below that 80-kilometer homosphere which we were talking about. So by 40 kilometers, what has happened? It has just become 3 millibars. So as you go upwards, what happens? The pressure declines at a very rapid rate. Okay. So you see, this is the atmospheric pressure. So you won't be able to remember the numbers, but can you make a graph even without numbers, just trying to show the trends? So here there is the air pressure in millibars, and here we are talking about the altitude in kilometers. So if you just want to remember, जो numbers मैंने बोले थे उसको remember कर सकते हो. At sea level, how much it was? It was 1013. 1 kilometer it was around 900 millibars. Then 5 kilometer it was 540 millibars, and by 40 kilometers height it just became 3 millibars. ठीक है? So there is a very, very sharp decline. Particularly, can you see if you go beyond 20 kilometers, can you see the very sharp decline which is taking place? The rarity of the atmosphere increases beyond this 20-kilometer height. And we will see that the lower layer, which we call it as the troposphere, it is located near to this height, little bit lower than this height. अभी देखते हैं. ठीक है? So there is one, we can understand the structure of the atmosphere in terms of atmospheric pressure. So that is one way. Then third way, which is the most popular, which we study in the books also, is on the basis of temperature. Basis of temperature. So on the basis of temperature, we find that something like this scenario happens. So initially in the lower layer up to around 18 kilometers, you will see it will vary in place to place. At poles it can be till 8 kilometers only. Towards equator it can be till 18 kilometers. So first we will find that the temperature declines. ठीक है? So here we are talking about, on this we are talking about temperature, and here we are talking about altitude. So initially what happens? Temperature declines. ठीक है? And if I talk about this decline, at this boundary of this lower layer which we'll see troposphere, it is almost reaching to what levels? Minus 60 degrees Celsius. ठीक है? Minus 60 degrees Celsius तक पहुंच जाता है. After that, we will find that there is a layer when there is isothermal conditions found. So what is isothermal conditions? It is essentially where there is no change in temperature. ठीक है? So isothermal conditions are found. Then we will be finding that after this the temperature begins to increase. ठीक है? It begins to increase. And if I just talk about, at it will increase till what height, till what level? Till it becomes near about 0 degree Celsius. ठीक है? Till it increases to about 0 degree Celsius. उसके बाद हमें क्या मिलता है? Again we will find that there is an isothermal conditions would be present. Then again it would begin to decline. ठीक है? It would reach to the lowest point, the lowest temperature found in the atmosphere, and this lowest temperature is how much? It is minus 90 degrees Celsius. Minus 90 degree Celsius. Then we find that it again an isothermal condition is found, and after that it continues to increase. ठीक है? It continues to increase. So this is the trend of temperature that we find within the atmosphere. Now, on the basis of this, what can be done? We can recognize several layers in the atmosphere. ठीक है? So, if we talk about this, here I am writing 8 kilometers and here I am writing 18 kilometers. थोड़ा ज़्यादा हो गया ऊपर. Here it is 18 kilometers. So here it is equator, where it is 18 kilometer. Here it is poles, 90 degree latitude. So 8 to 18 kilometers. So the layer which is located here, it is the troposphere. Troposphere. The boundary of the troposphere is the tropopause. This is referred to as the tropopause, the boundary of the troposphere. Then that means in the tropopause and the lower stratosphere, isothermal conditions are found. Okay? And we find that here there is height of 50 kilometers. So this is basically what? This is your stratosphere. Stratosphere. The boundary of the stratosphere is stratopause. Stratopause. Then what happens? Temperature, again an isothermal condition will be found in the lower part. Temperature again begins to decline. Okay? And if you talk about, this is the height of your 80 kilometers. And this layer is referred to as the mesosphere. Mesosphere. And here is the boundary which is mesopause. The mesopause. Then again isothermal conditions and temperature continues to rise. So this fourth layer is referred to as the thermosphere. Okay? We will see that thermosphere, the lower part of the thermosphere, there is concentration of ions. Okay? So on the basis of composition, the thermosphere can be further subdivided into two parts. The lower part is referred to as the ionosphere. Ionosphere. So around, it is around 660 kilometers, although this boundary is very variable. Books are also very writing different numbers. So the lower part is the ionosphere, and the upper part where the atmosphere is negligible, near to negligible, it becomes very rare. It is referred to as the exosphere. Okay? Exosphere. So this is the classification on the basis of temperature. ठीक है? सो लेट अस एक एक करके डिस्कस करते हैं. सबसे पहले बात करते हैं ट्रोपोस्फियर की. Troposphere. So in troposphere, what we will be finding that there is, first if we talk about the altitude of the troposphere, it is the lowermost layer. अभी हमने देखा था, here density of atmosphere is comparatively better than the upper layers. Altitude, it ranges from 8 to 18 kilometers. So 8 kilometers is found at the poles and 18 kilometer is found at the equator. At the equator. So reason is very simple. If I take, suppose, these two air masses, and suppose this is the air mass located at the poles, this one is located at the equator. So which of these places receives more insolation? Equator is receiving more insolation. Okay? We will see that if you talk about the atmosphere, essentially the atmosphere is more transparent to the incoming solar radiations. Heat budget में देखेंगे, it is almost behaving as transparent. That means the incoming solar radiations would come and heat the Earth's surface first. And what will happen? From below, the atmosphere will be mainly heated. So one principle which I told you yesterday also, the most significant first principle of climatology is what? Atmosphere is mainly heated from below. If you want to write it down. So first major principle of climatology is atmosphere is mainly heated from below. ठीक है? Now tell me, if here there is presence of cold conditions, here there is presence of hot or warm conditions, can I say hot and warm conditions would force the air to rise? Yes or no? Here the air will have tendency to rise. Tendency to rise. And if you talk about in the poles, what will happen? There will be tendency to sink. Tendency to sink because the air will become cooler, denser, and thus heavier. So it will have more tendency to sink. So can you understand why there is difference in the height of the tropopause? So at the equator, it is higher, at the poles, it is lower. That means the height of the tropopause, can we say, continuously declines from where to where? From equator towards poles. Okay? So it continuously declines from equator towards poles. So that is one aspect of the troposphere. Second important aspect of the troposphere is characterized by presence of lapse rate. Presence of lapse rate. ठीक है, lapse rate means temperature declines with altitude. जो अभी हमने देखा था, temperature declines with altitude. With altitude. ठीक है, अब इसके रीजन को अगर सबसे पहले देखें, what is the reason of this decline? So first is जो अभी हमने बात किया, atmosphere is mainly heated from below. Heated from below. Second, yesterday also I told you, density of atmosphere declines with altitude. With altitude. ठीक है, फर्स्ट पॉइंट समझ में आ गया, एटमॉस्फेयर इज मेनली हीटेड फ्रॉम बिलो. सो देखो, इफ यू आर अवेयर, अपने स्कूल में पढ़ा होगा तुमने, देर आर थ्री मेन मैकेनिज्म्स ऑफ ट्रांसफर ऑफ हीट. कौन कौन से होते हैं? एंड कन्वेक्शन, तीन तरह के होते हैं. सो हियर व्हेन वी आर टॉकिंग अबाउट द फर्स्ट पॉइंट, वी आर रेफरिंग टू कंडक्शन फिनोमेना. ठीक है, मेन जो फिनोमेना हम बात करें, कंडक्शन. सो इफ सपोज द लैंड इज हीटेड अप and the air in contact with this land is in contact with this land. So tell me, can we say air is a poor conductor of heat? It is a poor conductor of heat. So if air is a poor conductor of heat, can we say that with height, less heat would be conducted? As you go layer by layer, less heat would be conducted. So definitely that means what will happen? There will be decline in temperature with altitude. ठीक है, so that is first. Density of the atmosphere yesterday समझाया था. ठीक है, so there is two type of situation. If you talk about near the surface, this is the air. If you go upwards, this air expands because of lower density. So here, suppose there were these three particles. Here these three particles are now located like this. So here there is greater collision between these particles. That means there is greater work done. Greater work done means greater heat will be produced, there will be greater temperature. So you know, when we are working, जब हम ज़्यादा काम करते हैं तो पसीना निकलता है. So greater work done means there will be greater heat produced and thus there will be essentially higher temperature. As we go up, what is being done? There is less collision taking place between these air particles. Less work done, so what will happen? Temperature is declining. So that is the second point. Third point, concentration of greenhouse gases declines with altitude. It is a minor factor, but it is also a factor, because examination में, prelims में, sometimes they'll give you options and you'll have to identify. Okay, so even if it is minor, but it is correct. Concentration of greenhouse gases declines with altitude. So we just now said one of the way of heat transfer is radiations. Okay, where radiations are emitted. So the greenhouse gases are the ones who would do what? Who would trap these radiations. Like yesterday we saw the two very important greenhouse gases, कौन सी थी? Water vapor and carbon dioxide. Okay, if you just take the example of water vapor, up to the height of 6 kilometer, we find that 90% of the water vapor of the atmosphere is found. Okay, up to the height of 6 kilometer, 90% of the water vapor in the atmosphere is found. उसके ऊपर हमने देखा था 99% was present till the troposphere. So these are the reasons why there is decline in temperature. Now, to talk about this lapse rate, we are using two terms. One is what we call it as the normal lapse rate. नॉर्मल लैप्स रेट. ठीक है, सो नॉर्मल लैप्स रेट का मतलब यहां पर नॉर्मल क्या है? यहां पर नॉर्मल का मतलब है मीन या फिर एवरेज. मीन और द एवरेज. ठीक है, सो व्हाट इज द मीन और एवरेज लैप्स रेट? इट इज 6.5 डिग्री सेल्सियस पर kilometer. So it is at the rate of 6.5 degrees Celsius per kilometer. So with every kilometer height, what will happen? There will be decline of 6.5 degrees Celsius. Temperature would be declining. So this is the normal lapse rate. ठीक है? However, real world situations would be different. ठीक है? अब देखो, suppose we are present at a place where it is very cold. ठीक है, and we are present at another area where it is very hot. ठीक है, so tell me, can I say जहां पर cold होगा वहां पर, अगर सपोज करो कि मैं लैप्स रेट की बात करता हूं, here there is temperature and this is altitude, can I say the decline will be less steeper? होगा, it will be less steeper. Already it is very cold. On the other hand, can I say here the decline can be very steep? It is very hot near the surface. ठीक है, so in the real world what will happen? It would be variable. So this, to show this variability, we are using another term. We call it as the environmental lapse rate. Environmental lapse rate. ठीक है, so environmental lapse rate क्या है? It is the real lapse rate found in any particular place at a particular point of time. It will be variable in space and time. So I hope lapse rate समझ में आ गया. Okay, so that is one. Third thing which we need to know about the troposphere from our perspective is that majority of weather phenomena, they occur where? They are occurring in the troposphere. So majority of weather phenomena occur in the troposphere. Occur in the troposphere. रीजन yesterday हमने देखा था, because 99% of the water vapor is contained within the troposphere. Because 99% of the water vapor is contained within the troposphere. ठीक है. So this is another very important thing which we have to know. अब इसमें देखोगे, I have used the word majority. अगर स्टेटमेंट आता है सपोज प्रीलिम्स में ऑल ऑफ द वेदर फिनोमेना occurs in the troposphere, it is wrong. ठीक है. Majority of the weather phenomena is occurring in the troposphere. That means some of the weather phenomena do occur above it, and where they are occurring mainly we will see in the stratosphere. So that is something which you have to know. In fact, because of this, the jet planes, they are flying where? Not in the troposphere but in the stratosphere. Okay. So that is one thing we need to know. Then another thing, we need to know about the character of tropopause. Already हमने tropopause के बारे में एक चीज देख लिया है. Tropopause. ठीक है. So tropopause की अगर बात करें तो very important thing is tropopause behaves as a lid or cover. लिख लो इसको. Tropopause behaves as a lid or cover. As a lid or cover over the troposphere. As a lid or cover over the troposphere. ठीक है. मैं इसको कोशिश करता हूं 2 मिनट में समझाने की. नहीं समझ में आता है, सपोज इट विल बिकम लेटर क्लियर टू यू व्हेन वी विल बी टॉकिंग अबाउट द टॉपिक ऑफ स्टेबिलिटी इनस्टेबिलिटी. वहां पर ज्यादा क्लैरिटी आएगी. फिर भी थोड़ी सी समझाने की कोशिश करता हूं. सो सपोज देयर इज दिस एटमॉस्फेयर प्रेजेंट. ठीक है. सो इस एटमॉस्फेयर में हमने क्या देखा? एज वी गो विथ ऑल्टीट्यूड, व्हाट वाज हैपनिंग विथ टेम्परेचर? There was decline in temperature. We saw that there was environmental lapse rate which is applicable. ठीक है. सो सपोज करो, एक छोटा सा एग्जांपल लेते हैं. सपोज करो कि एनवायरमेंटल लैप्स रेट जो है इट इज 8 डिग्री सेल्सियस पर किलोमीटर. जस्ट एज्यूम इट इज 8 डिग्री सेल्सियस पर किलोमीटर. ठीक है. सपोज एक एयर है, एक पार्सल ऑफ एयर, दिस हैज बीन फोर्स्ड टू गेट लिफ्टेड. ठीक है. बाद में देखेंगे एयर के बजाय क्या होता है? एयर मासेस एंड एयर पार्सल्स विच बिहेव एज अ क्लोज सिस्टम. यानी कि उसके अंदर जो चेंज हो रहा है वो उसी के अंदर रहेगा. इट विल बी बिहेविंग एज अ क्लोज सिस्टम. सो व्हाट विल हैपन? दिस पार्सल ऑफ एयर इज राइजिंग. सो अगर ये राइज कर रहा है, इट इज गोइंग इनटू लेस डेंस एटमॉस्फेयर. सो विल इट हैव टेंडेंसी टू एक्सपैंड? इट विल एक्सपैंड. सो द 3 पार्टिकल्स, वो जो 3 भाई थे, अब ये अलग अलग हो गए. They will be less fighting, and since they are less fighting, what will happen with the temperature within this air mass? Will it decline? There will be definitely decline in the temperature. बाद में देखेंगे, we call it as the adiabatic lapse rate. Adiabatic lapse rate. ठीक है. So the lapse rate which is applicable in a closed system, that is adiabatic lapse rate. So for this parcel to rise, can I say it should be actually this lapse rate should be less than this? Yes or no? So suppose ये lapse rate is 7 डिग्री सेल्सियस पर किलोमीटर. सो सपोज यहां पे दोनों 30 डिग्री सेल्सियस था टेम्परेचर. अगर हम 1 किलोमीटर पे देखें तो ये कितना हो जाएगा? 22, एंड दिस विल बिकम 23. सो विच वन इज वार्मर? द राइजिंग पार्सल. It is warmer. Thus, will it be lighter and buoyant also? It will be lighter and buoyant, so it will continue to rise. होगा. So, जब तक ये condition है, then what will happen? Till that time, it will keep on rising. till this parcel of air is warmer than the surrounding, it will keep on rising. But हमने क्या देखा, ट्रोपोपॉज पे वहां से हमने क्या देखा, देर इज आइसोथर्मल कंडीशन, उसके बाद इनफैक्ट टेम्परेचर ऑल्सो इंक्रीजेस. ठीक है, it also increases. So can I say at tropopause when the temperature इसमें environment में it ceases to decline now, then will the ascent of this air parcel stop? सीधी सी बात है, because इसमें तो decline होता रहेगा. It is more related with the reduction in density. So this air parcel will keep on expanding and within it the temperature decline will continue. बट सराउंडिंग एटमॉस्फेयर में ऐसा नहीं हो रहा है. वहां पर टेम्परेचर इज बिकमिंग फर्स्ट आइसोथर्मल देन इवन इंक्रीजिंग. ठीक है, दैट मीन्स with height this rising air parcel will not remain warmer and thus less denser and thus buoyant. It will become what? It will become cooler and thus heavier. So that means it won't be able to rise. So what happens? The tropopause behaves as a lid over the atmosphere. ठीक है, बहुत ज्यादा इसके implications हैं, बाद में भी देखेंगे. For example, you might have, if you have read your NCERT, देखा है cumulonimbus clouds ऐसे हो जाते हैं, anvil head. So why it happens? Because the air cannot further cross the tropopause, so it has only one way to laterally spread. And thus what happens, there is formation of the anvil head. ठीक है, बाद में देखेंगे प्रेशर के टॉपिक में. when there is a suppose low pressure, surface पे suppose there is a low pressure is always characterized by convergence of air. ठीक है, so there is convergence of air taking place. So this converging air, it will go upwards. नीचे जमीन खोद के तो चला नहीं जाएगा, so it will go upwards and as soon as it reaches the tropopause, अब कहां जाएगा? It will diverge. ठीक है, it will diverge. So बाद में देखेंगे wherever there is low pressure, always above it there will be high pressure and vice versa. ठीक है, so again this is a very important property of the tropopause which has huge weather and climatic significance. ठीक है, so this is basically your troposphere. Moving on, next पर आते हैं, that is your stratosphere. Stratosphere. So देखो stratosphere को how why stratosphere was named like this as stratosphere. It simply means there is straight temperature. That means there is isothermal temperature in the stratosphere. ठीक है, but did we saw it is wrong? Is isothermal condition just found in the lower part of the stratosphere? ठीक है, above in the later part of the stratosphere the temperature begins to rise. ठीक है, so why it was named like this? Main reason was because earlier our main information about the atmosphere came from the radio sonde balloons which were sent upwards. ठीक है, so they gave us most of the information about the atmosphere. So essentially, if you talk about these radio sonde balloons, can I say they will face the same problem? Tropopause वहां पर जाके रुक जाएगा. ठीक है, so ultimately it was realized that there was isothermal conditions due to which it was unable to rise above that. So scientists assumed initially that the entire stratosphere the same isothermal conditions are existing. ठीक है, and that is why they named it stratosphere. But again it is not the case. We know that in stratosphere what is the situation? Lower part there is isothermal conditions are found, but in much of stratosphere or rest of stratosphere temperature increases with altitude. ऑल्टीट्यूड, ठीक है। सो सबसे पहले इस टेम्परेचर इंक्रीज को समझाता हूं. Why is temperature increasing with altitude? Because our atmosphere has a property. It does selective absorption of insolation at particular heights. ठीक है. So within the atmosphere there is selective absorption of the incoming solar radiations at particular height. You know, here there is selective absorption of ultraviolet rays by the ozone. We have already seen in this layer there is presence of ozonosphere. It is a sub layer within this stratosphere. ठीक है. So due to this selective absorption property, we find that there is temperature increase seen in the stratosphere. Why there is isothermal? सिंपल सी बात है. देखो, आइसोथर्मल भी इसी वजह से, बिकॉज देर इज एब्जॉर्प्शन टेकिंग प्लेस, सेलेक्टिव एब्जॉर्प्शन टेकिंग प्लेस. ठीक है. सो नॉर्मली क्या होना चाहिए? एज यू गो अपवर्ड्स टेम्परेचर शुड कंटिन्यू टू डिक्लाइन. ठीक है. दिस शुड बी द नॉर्मल कंडीशन. बट हमें क्या मिल रहा है? एक हाइट के बाद देर इज ऑल्सो बिगिनिंग ऑफ एब्जॉर्प्शन ऑफ इंसोलेशन. ठीक है. Did we saw yesterday that in the lower part the concentration of ozone is less? देखा था हमने. So there is less concentration of ozone. As we were going upwards, what was happening to the concentration of ozone? It was increasing. ठीक है. There was more and more absorption taking place with height. याद है, देखा था हमने 60 to 40 में सबसे ज्यादा फॉर्मेशन एब्जॉर्प्शन हो रहा था. So it was more and more taking place. So यहां पर क्यों आइसोथर्मल बन जा रहा है? Because the absorption, the heat absorption matches with the loss of heat which is taking place. Thus what we find, there is isothermal condition which is found. ठीक है. So यहां पर क्यों आइसोथर्मल है? Because the loss of heat becomes equal to addition of heat. लॉस ऑफ हीट किस लिए हो रहा है? बिकॉज ऑफ द फिनोमेना ऑफ लैप्स रेट. देखा था अभी हमने, 3 रीजंस देखे थे. डेंसिटी, हीटेड फ्रॉम बिलो, वो सभी रीजंस थे. सो बिकॉज ऑफ दैट लॉस ऑफ हीट इज टेकिंग प्लेस. एडिशन ऑफ हीट क्यों हो रहा है? बिकॉज ऑफ सेलेक्टिव एब्जॉर्प्शन. सो इन दिस लेयर both of these become equal and thus isothermal conditions you are finding. So that is the case of stratosphere. Later, through the use of satellites, we were able to essentially know the real characteristics of the stratosphere. Then, if you talk about, there is the third mesosphere. Third layer, that is the mesosphere, the middle layer. और mesosphere में the thing is, if you are aware, mesosphere is lying between the height of 50 to 80 kilometers. अभी देखा हमने. ठीक है. अब प्रॉब्लम ये है कि mesosphere is lying at a height where there is the low earth orbit satellites भी नहीं जाती हैं और जो high earth orbit satellites भी नहीं जाती हैं. It is out of the range of the satellites where the satellites are located. ठीक है. तो the actual information about the mesosphere is still very limited with the scientists. ठीक है. So if you talk about under such circumstances, what we do, we assume that the lapse rate would be applicable in the mesosphere. So what we find in mesosphere, there is lapse rate applies. It means that temperature declines with altitude. Temperature declines with altitude. ठीक है. So बाद में human geography में we will study one topic, positivism. So positivism is a philosophy which says that science is the main, scientific method is a better method of study. Okay, but we will see even positivism claims that there is relativity, phenomena of relativity. That means what we are treating today as science, it depends upon the progress of the society. In future, what we think today is correct may not be correct in the future as more technologies develop. ठीक है. So very importantly, even if you know many things, don't be arrogant because you don't know the whole truth. ठीक है. So that is what we are saying, because we have in the mesosphere limited information and we don't know, maybe in future there might be several changes of what we know. Whatever, it declines with altitude, and the lowest temperature in the atmosphere, lowest temperature in the atmosphere, that is minus 90 degrees Celsius, is encountered at the boundary of the mesosphere, that is mesopause. It is encountered at the boundary of the mesosphere, that is the mesopause. ठीक है. सो जैसा कि अभी मैंने बताया, we our information about the mesosphere is very limited, so there is not much to discuss about the mesosphere. Then coming to the thermosphere. Thermosphere. So what is happening in the thermosphere? As we saw, there is increase in temperature. Within the thermosphere, lower part is isothermal, but there, after that there is increase in temperature. And why there is increase in temperature? Again here, there is selective absorption of short wavelength radiations. Short wavelength radiations is taking place. Some short wavelength radiations like X-rays are absorbed in this thermosphere, and thus within the thermosphere, within the entire thermosphere, temperature increases with altitude. Okay. Now, in thermosphere, what happens? Temperatures become extraordinarily high. Temperatures become extraordinarily high. So, for example, at the boundary of ionosphere, it is expected to reach around how much? 120 degrees Celsius. 120 degrees Celsius. So it becomes extraordinarily high. ठीक है. So बहुत ज़्यादा हो जाता है. But you can understand the extraordinarily high temperature here is very different from the extraordinarily high temperature near the surface. ठीक है. सरफेस पे अगर सपोज करो कि एसी चल रहा है, आई एम फीलिंग कूल. Why? Because cold air is coming and hitting my body. So I have that sensation of cool. If the air is hot, it comes and hit my body, I'll feel warm. So that is the reason why I am feeling this hot and warm. In here, at this height, the atmosphere becomes so much rare. that the particle of the atmosphere coming and hitting your body will be a very rare phenomena. Okay, it will be quite a rare phenomena. So even if it comes and hits your body, it will be like a pinch, a needle pinch. It has hit you. Okay, so it is a different type of situation at such heights. So why? Because there is very rare atmosphere present. So that is one aspect of thermosphere. As we said, the lower part of the thermosphere is ionosphere. The lower part of the thermosphere is the ionosphere. So within the ionosphere, first of all, why we are calling this layer as the ionosphere? Because there is concentration of ions. Concentration of ions taking place in this layer. So you know what are ions? Charged particles. So there is concentration of ions taking place here. So mainly this concentration of ions is outcome of ionization of nitrogen and some oxygen particles which are found here. So because of that there is the phenomena of ionization which has taken place here. Now if we talk about the ionosphere, you know already know what is the property of ionosphere. It reflects the radio waves. अभी हम उसकी बात करेंगे. But even within the ionosphere, what we find, we said that ionosphere is almost from 80 kilometer to around 640 650 kilometer. कुछ books में 590 लिखा हुआ है, whatever. It is very variable figure given. So this is the level of the ionosphere. Now what we find, this lower part of the ionosphere, the lower part of the ionosphere, it has characteristic of it disappears at night. The lower part of the ionosphere, it disappears at night, while the rest of the ionosphere, it is permanent. So the lower part disappears at night and the upper is permanent in nature. Okay. Now, very important thing is, question arises why it disappears at night. ठीक है, तो इसको हम पहले डिफरेंशिएट करते हैं. What is the difference between these layer? The main difference is in the concentration of ions. ठीक है, so in the lower part what we find, there is high concentration of ions taking place or is found. Here there is lower concentration. Here there is lower concentration of ions found. ठीक है. Now tell me, अगर ions हैं तो will they be also getting neutralized over a period of time? वो neutralize भी होते रहेंगे. So there is both things taking place, ionization and neutralization. ठीक है. So to maintain this high concentration of ions, tell me, can we say that there is continuous process of ionization should take place? होना चाहिए. And this ionization can occur only during the daytime when the sun rays are available. Night में तो हो नहीं सकता है. ठीक है. So why it disappears during the night? Because during the night there is no ionization taking place, as there are no sun rays. So during the night there is no ionization taking place. as the sun rays disappear. So what will happen because of that? Can we say the concentration of ions declines in this lower layer? So there is decline in the concentration. There is decline in the concentration of ions in the lower layer. और tell me, इसकी पहचान क्या थी? It was high concentration of ions. So if it is not found, this means what? It has disappeared. On the other hand, in this part, the rest of the ionosphere, what we find, there is already lower concentration of ions. So even if there is no sun, this much concentration over lower concentration would be maintained. Okay? That is why we are saying it is permanent. It is present throughout the day. So that is the case of ionosphere. And we'll later also see ionosphere is very, very important because first it reflects the radio waves back to the earth, thus helps us in what? Communication. It is helping in communication. We will see another very important phenomenon of ionosphere later. Part of the geomagnetic field is also produced in the ionosphere. Part of the geomagnetic field is also produced in the ionosphere. Ionosphere. अभी ये समझ में नहीं आएगा when we'll talk about geomagnetism. That time you'll understand. ठीक है? Very important thing, the geomagnetism which is present here, it is in this what happens because there is charged particles. So when there is solar winds coming, ठीक है? So what will happen? The solar winds would also carry the heliomagnetic field. That means the sun's magnetic field. That means in simple words, charged particles from the sun. And you know, these charged particles sometimes can break through the earth's magnetic field and enter in the earth's atmosphere. So when they are entering in the earth's atmosphere, they get concentrated in the ionosphere region, and you might have heard about those aurora lights. Okay? So the aurora lights, actually the glowing of the aurora lights takes place where? In the ionosphere, particularly along the poles in the ionosphere. Okay? So that is the main things you need to know about the ionosphere. It is around, if you talk about somewhere, it is 180 किलोमीटर के आसपास है, ज्यादा नहीं है. लोअर 100 किलोमीटर जो होता है एनोस्फीयर का. हम्म. जब हम ओजोनोस्फीयर में जाते हैं तो देयर इज वेरी हाई, कंपैरेटिवली हायर डेंसिटी ऑफ द एटमॉस्फेयर. ठीक है? और देखेंगे देयर द प्रोसेस ऑफ न्यूट्रलाइजेशन, जो ओजोन का डिसोसिएशन, इट इज अ डिफरेंट थिंग ऑल टुगेदर. तो वहां पे अलग फिनोमेना चल रहा है. तो ओजोन इज एक्चुअली प्रेजेंट, इट इज नॉट, इट इज मोर परमानेंट. बियॉन्ड द आइनोस्फीयर व्हाट इज फाउंड? एक्सोस्फीयर. और एक्सोस्फीयर के बारे में ज्यादा कुछ लिखने के लिए, बोलने के लिए नहीं है. सिंपली वी कैन से एक्सोस्फीयर इज द आउटर लेयर ऑफ द अर्थ. इट इज द आउटर मोस्ट लेयर ऑफ द अर्थ. एंड एज वी सेड, what will be the property of exosphere? One, does the temperature increase continues? Yes, it is part of the thermosphere. So temperature continues to increase here. One, here the atmosphere becomes highly rare. It is becoming highly rare. Okay, it becomes so much rare that it is difficult to identify where the boundary of the atmosphere lies. It becomes so much rare. It is difficult to identify where the boundary of the atmosphere lies. So there are various accounts. So some would say that it is not more than, if you talk about 2500 kilometers, some would say it is even up to 36,000 kilometers. Okay, so again there is no clarity with respect to where the actual boundary of the atmosphere lies. So this is your structure of the atmosphere. I'll give you one question, एक question लिखो. Identify and explain the vertical belts of temperature in the atmosphere. In the atmosphere. So I'll give you 2 minutes. Think. कैसे लिखोगे अगर suppose if you have to write an answer 150 words. Okay. So suppose I was writing, what I will do, I'll start with an introduction, and clearly there are two parts. You have to identify and you have to also explain. ठीक है? So if you talk about introduction में हम क्या लिख सकते हैं? एक जो जनरल पैटर्न है उसको उसकी समरी लिख सकते हैं. ठीक है? So here we can write the atmosphere. The atmosphere is or consists of two normal layers characterized by, in fact layer मैंने word use किया, always you use the keyword which is used in the question. ठीक है? So it is more like this कि अगर सपोज मैं बहुत अच्छा पढ़ा रहा हूँ और बहुत अच्छा टीचर हूँ और मैं तुम लोगों को बार बार नहीं बताऊं कि मैं बहुत अच्छा पढ़ा रहा हूँ, बहुत अच्छा टीचर हूँ, तुम लोगों को समझ में नहीं आएगा, रेस्पेक्ट ही नहीं होगी. ठीक है? सो सेम थिंग इन द क्वेश्चन. What you have to do, you have to tell the examiner again and again what you have asked. I am writing only that. And how you'll be able to do? By using the keywords used in the question. ठीक है? So there are two normal belts characterized by lapse rate or application of lapse rate, comma, two belts characterized by inversion of temperature, and three isothermal transitional belts. Three isothermal transitional belts, because they are boundaries, transition zones. सो सेम चीज अब मैंने क्या किया, इसको एक अलग तरीके से लिखा, आंसर के पॉइंट ऑफ व्यू से थोड़ा सा एनरिच कर दिया। ठीक है, जो सिलेबस में हम पढ़ते हैं वहां पर वो टर्म्स, टर्मिनोलॉजीज यूज की। ठीक है, सो मैंने यूज किया इन्वर्जन ऑफ टेम्परेचर, क्योंकि वहां पर देर इज राइज ऑफ टेम्परेचर टेकिंग प्लेस, विच इज एसेंशियली द inversion of temperature. After that, ideally, what should be done? There should be a diagram, and each of these belts and the explanation of the temperature situation. ठीक है, आइसोथर्मल को एक साथ समझा सकते हो तीनों को, बट बाकी जो बेल्ट्स हैं उनको एक एक करके वी ऑलरेडी एक्सप्लेन कि क्यों ऐसा हो रहा है। ठीक है, सो दैट इज बेसिकली हाउ यू विल बी राइटिंग। वन मोर थिंग यू कुड हैव यूज्ड एसेंशियली टाइम। कभी कभी क्या होता है कि हमारे पास टाइम नहीं होता, अगर टाइम है तो आइडियली राइट इट डाउन। इफ यू डोंट हैव टाइम यू कैन यूज द डायग्राम, डायग्राम में भी एरो बना करके कॉज लिख सकते हैं। ठीक है, so that will also do. So sometimes you'll have to save time at places. Okay, so that is basically the uh, structure of the atmosphere. Now let us move on to our next topic, and the next topic is, अब हम आते हैं अपने most important topic पर, that is insulation. 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 ठीक है, so here what we are going to do, we'll see the concept of insulation. We will talk about the factors affecting its distribution, and we will see the distribution. Distribution of insulation. ठीक है, although this topic is not mentioned in the syllabus, पहले भी बताया, there is a question which has been asked, difference between insulation and temperature. Okay, so concept की बात करें, what essentially is insulation? So it is a short form of incoming solar radiations. Incoming solar radiations. Incoming solar radiation. Very important aspect. Sorry. Radiation. So very, very important aspect of this term here is radiation. So you know what is radiation? Radiation is a method of heat transfer. It is a way of heat transfer through, it doesn't requires any medium. No medium is required through the radiation, in radiation. Now very important thing, अगर हम देखें तो there are number of factors which would determine the type of radiations which would be coming. ठीक है, Radiations essentially can be long wave or short wave radiations. The one which is coming from the sun, it is essentially the short wave. Majority of it is in the short wave. So if you talk about one very important factor which is determining factor is the surface temperature. Surface temperature of the body which is emitting radiations. Okay. Now you can very clearly understand if you are talking about the sun. The surface temperature of the sun is over 5000 degree Celsius. Okay. So the surface temperature of the sun is over 5000 डिग्री सेल्सियस से ज्यादा है. ऑन द अदर हैंड अगर हम अर्थ की बात करें, अर्थ का सरफेस टेम्परेचर कितना है? इट इज समवेयर अराउंड 16-17 डिग्री सेल्सियस के आसपास है. ठीक है. सो 16 डिग्री सेल्सियस जो एवरेज टेम्परेचर अगर है मान ले तो. सो व्हाट इज हैपनिंग? सरफेस टेम्परेचर, द टेम्परेचर इज इनवर्सली प्रोपोर्शनल टू द वेवलेंथ. ठीक है. सो greater the surface temperature, shorter will be the wavelength. So most of the energy will be coming in the form of short wavelength radiation. Okay? So most of the energy coming from the sun, it is in the form of short wavelength radiation. Short wavelength radiation. On the other hand, if you talk about in case of earth, much of the energy emitted from the earth is in the form of long wavelength radiations, and these are also referred to as the terrestrial radiations. These are also referred to as the terrestrial radiations. Just give me 1 minute. Okay, so can you see? This is the wavelength spectrum in which these radiations are coming. So sun's surface temperature is over 10,000 degree Fahrenheit. So can you see what is the distribution, which is the wavelength in case of sun? Around 7% if you talk about it is the ultraviolet. If you talk about 43%, it is coming as in the form of visible light, which is also a form of short wavelength radiations. And rest if you talk about it is also coming in the form of 49%. Again, these are short wavelength radiation. You see, till here micrometers wavelength, they are referred to as the short wavelength radiation. So majority of energy which is coming from the sun, it is in the form of short wavelength radiations. On the other hand, you see in case of earth, what is the average surface temperature? It is 59 degree Fahrenheit. So here what we find, much of the energy which is emitted from the earth, it is in the form of long wavelength radiation. Can you see? It is mostly above 10 micrometers. Okay? So there is a peak around the 10 micrometers, between 10 to 20 micrometer, most of the energy is emitted from the earth. So that is basically the long wavelength radiation. अब देखो इसका impact क्या है? You see this diagram. This is the various gases which are present in the atmosphere. There is nitrogen, there is carbon dioxide, there is water vapor, there is oxygen and ozone. Okay? So these are the various gases which are present in the atmosphere. Can you see that much of these gases for insolation, there is no absorption taking place. Can you see that? These peaks, ये जो shading बनी हुई है, this shows the absorption which is occurring. So can you see for much of it there is hardly any absorption. Only for oxygen and ozone, can you see in the short wavelength, the ultraviolet part of the spectrum, there is absorption taking place. Okay? All other, can you see there is no absorption. That means the atmosphere practically what it does, it is behaving as a transparent medium for the incoming solar radiation. There is no absorption of insolation taking place directly in the atmosphere except at selective heights. Okay? But when it comes to the radiations emitted by the earth, can you see there is some absorption by the nitrogen, but it is not in the peak of the energy which is emitted by the earth in the peak spectrum. So can you see where this peak spectrum is taking place? Water vapor. Do you remember I told you water vapor is a very powerful greenhouse gas. Okay? So there it is taking place. Also lots of energy is trapped where? By carbon dioxide. Okay? So these are the two very important greenhouse gases. There are others also we'll talk about in climate change, but that is what is happening with the incoming solar radiations. So these incoming solar radiations are able to reach the earth's surface. We will see, although not all, because some of it is reflected back. So it is able to reach the earth's surface because our atmosphere behaves as a transparent medium to them, and it is able to heat the surface of the earth, which in turn leads to the heating of the atmosphere from below. So that is the case of insolation. Okay? There is another term associated with that. We use a term solar constant. Solar constant. So what is solar constant? Solar constant is the total energy which is received, or total insolation received at the boundary of earth atmosphere. It is the total insolation received at the boundary of the earth atmosphere system. So earth and atmosphere behave as one system. Okay? So what is solar constant? The energy which we are receiving here, because once it begins to enter into atmosphere, there will be several processes starting to take place. Okay? So this is what we are calling it as solar constant. Now, important thing is, can we say that reality is very complex? There are so many variabilities. Now, if I try to study reality as it is, तो फिर तो कुछ समझ में ही नहीं आएगा, because there are so many random scores of factors which are involved. ठीक है? सो किसी चीज को समझने के लिए एक तरीका जो होता है, सपोज मेनी ऑफ यू आर इंजीनियर्स. ठीक है? तो घर में कोई भी इलेक्ट्रॉनिक सामान खराब हो जाता है तो किसकी तरफ देखते हैं? इंजीनियर्स की तरफ. ठीक कर देगा, भले ही वो किसी और ब्रांच का इंजीनियर हो, but everyone would be looking towards you. So suppose you are stuck in a situation where you have to solve such type of problem. So suppose तुम्हें दे दिया गया कि ये रिमोट ठीक कर, और रिमोट के बारे में आर भी नहीं पता. What you will do? Can I say you will start opening it, क्योंकि इज्जत का सवाल है, and essentially you'll find a constant point. पहले देखोगे कि how it is organized and a particular constant point, and then you'll try to open it. ठीक है? So एक constant तो रखना पड़ेगा. ठीक है? So here also what we are doing, if we assume that the sun rays are very variable, which are actually they are. ठीक है, they are very variable in time. If we assume that, then we will not be able to understand the processes which are taking place in the atmosphere. So to simplify these processes and understand them, at first stage what we are doing, we are assuming that the sunlight coming from the sun, it is basically what, it is a constant. ठीक है, और इसीलिए हम इसको क्या बोल रहे हैं, सोलर कांस्टेंट. So it is what, it is theoretical concept. First of all, it is a more theoretical concept. And if you talk about the solar constant, it is around 1.96 calories per centimeter square per second. So around 2 calories per centimeter square per second. This is the solar constant which is received. Needless to say, I told you it is more theoretical to understand the climatic processes. In reality, it is highly variable. Okay, so that is what is solar constant. So here we will be finding at Earth atmosphere boundary this much of energy is received. Now, so that is what we mean by insolation. अब आगे बढ़ते हैं. Factors affecting distribution of insolation. Distribution of insolation. So देखो, books में पढ़ोगे तो they are very randomly given. All these factors, they will write too many factors and in a very random fashion. इससे क्या होता है, याद नहीं होता पहले तो. So book में बहुत information है, but it is very scattered all over the place. So what we need to do, if we want to remember, we need to arrange it properly in some fashion. ठीक है? So factors affecting distribution of insolation, we can say that there are two type of factors. Two category of factors which are affecting the distribution of insolation. First category of factors is, I can call them as the primary factors. The primary factors. Second, if you talk about, are the secondary, या फिर हम इसको कह सकते हैं मॉडिफाइंग. secondary or modifying factors. So primary factors and the modifying factors. Primary factors में बहुत सारे होते हैं. Three main हम identify करते हैं, which explains all of them. So first, if you talk about, is the angle of incidence. Angle of incidence. ठीक है. Second, if you talk about, it is the tilt of Earth's rotational axis. So you know, it is Earth's rotational axis is tilted by 23.5 degree. So that is second very important factor. Third, if you talk about, it is the duration of sunlight. So angle of incidence, tilt of Earth's rotational axis, duration of sunlight. So एक एक करके start करते हैं. First, let us talk about the angle of incidence. Angle of incidence. ठीक है. अब देखो, why there is angle of incidence? What it means? It means that the tilt of the sun rays. ठीक है. What is the tilt of the sun rays? So it, with respect to Earth's surface or surface of that place. What is the tilt? Now, assume, suppose हमारा अर्थ फ्लैट होता, ठीक है? If our earth was flat, we are assuming that the sun rays are coming from infinity, ठीक है? So if they are coming from infinity, पढ़ा होगा, they are parallel rays. So that means all the places on the earth would have received same amount of sunlight. ठीक है? There would have been no difference. However, it is not the case. What is the reality? Our earth is an oblate spheroid. Oblate spheroid. ठीक है? And because of that, now take these sun rays coming from infinity. So tell me, if I take the angle of sun rays lying here, so suppose this is the tangent with respect to this surface, it is highly tilted. ठीक है? Near equator, can you see, suppose if I take this as the tangent, at equator it will be 90 degree. ठीक है? As I am going from equator towards poles, what happens? It becomes more and more tilted. More and more tilted. ठीक है? So now see how this tilt affects the total insolation received. So suppose करो मैं क्या करता हूं, एक टॉर्च ले लेता हूं, and if I keep the torch at 90 degree on this board with a 90-degree angle, can I say it will heat up this much area, suppose? But if I tilt the angle of the torch, now same amount of energy will be heating a bigger area. Yes or no? It is but obvious. So in this first case, tell me, can we say that per unit area energy received is higher? Here per unit area energy received declines. As it becomes more and more tilted, it continues to decline. ठीक है? So this is the first impact of the tilt. There is another impact of the tilt. So we are saying that suppose this is our earth, but remember there is also a layer of the atmosphere. ठीक है? So here when the sun rays are vertical, they have to cross how many atmosphere? One atmosphere. ठीक है? But when the sun rays become more tilted, they have to cross more atmosphere, more than one atmosphere. ठीक है? So when these sun rays are crossing, what will happen? Will there be more loss of energy? ठीक है? There will be more loss of energy. So with the tilt, what will happen? There will be less and less energy received. So angle of incidence is the most primary factor which determines the insolation. समझ में आ गया ये? Okay. Then second पर आते हैं, tilt of Earth's rotational axis. Tilt of the Earth's rotational axis. Okay. So again see two situations to understand it. Suppose there is a situation where the Earth's rotational axis is not tilted. ठीक है, to the plane of elliptic. So it is not tilted. So it is more like, suppose this. So oblate spheroid में क्या होता है? There is bulging at the equator and there is compression at the poles. ठीक है. So in this scenario, suppose there is this our sun. Can you see the sun rays would hardly heat the poles? Almost, if you talk about, hardly any energy would be received at the poles. Can you see that? Because at the poles the earth is compressed. So that means the poles will never receive any direct sunlight if this was the case. But, and tell me, equator, will it receive direct sunlight throughout the year? All the 365 days, it will be receiving direct sunlight. But we know that this is not the case because the Earth's axis of rotation is tilted. Okay? So we will see there will be various position. So it is tilted by 23.5 degree. So this is one position. This is another position. This is the other position. These two positions are the equinoxes. Okay? This is equinox and this is the equinox position. This is the solstice of the northern hemisphere. This is the solstice position of the summer hemisphere. ठीक है? So tell me, can we say that equinoxes the direct sunlight is received at the equator? At the equator. But during the solstice, where the direct energy is received? At the tropics. Okay? So direct sunlight falls in the tropics rather than at the equator. Now, when there is this solstice position, can you see that actually now the poles is even receiving sunlight? Okay? So at this point of time, the poles are also receiving sunlight. So here, northern hemisphere, in this case, very clearly the southern hemisphere. Okay? So now understand this point. So see, there are two curves drawn. If there was no tilt, in case of there is the axis of rotation is not tilted, this is perpendicular axis of rotation. So can you see at poles, the amount of energy received is near zero. And it keeps on increasing, and it is highest where? At the equator, near the equator. Okay? But this is the not the case because we know that the axis of rotation is what? It is tilted. So what is the case? Here. So at the boundary of the atmosphere, it is given in watts per meter square per year. Okay. It is more than 400 watts per meter square per year of energy is received at the near the equator. And even at the poles, can you see a little less than 200 watts per meter square per year energy is received even at the pole. So please draw this diagram fast. So notice two things. In lower latitudes, can you see the actual energy received is lesser than the case of perpendicular axis, because throughout the year at equator it is not vertical. So what has happened? There is little bit reduction has taken place. What has happened in the higher latitudes because of this tilt? Has it increased the actual amount of energy received? It is greater. ऑल्सो नोटिस फ्यू थिंग्स, जब ऐसा कोई डायग्राम बनाना होगा तो मुझे क्या करना होता है? तो कोऑर्डिनेट्स याद रखने होते हैं. You'll just remember the coordinates. For example, where this crossing is taking place, around 45 degree, around 45 degree latitude. ठीक है? Now, this booklet which I am showing, we will be giving you this booklet. अभी मिला नहीं होगा? नहीं मिला है ना? मिल गया है? नहीं मिला है ना? जानबूझ के नहीं मिला. Because I don't want you to have it now. Remember हमने first day एक rule बनाया था. What was that rule? The reverse approach. First we'll focus upon the content we have, the classes में जो हम पढ़ रहे हैं. Once we feel that we have done the enough revision, then we will go to any book or booklet. ठीक है? अभी दे दूंगा तो वो मुझे पता है कि वो सबके कीड़े होते हैं अंदर. You will not stop, because always it will be the case कि पूरी तरह से कोई चीज समझ में नहीं आती. And then we'll look towards more and more content. ठीक है? So that is the second primary factor which is affecting the distribution of insolation. Third primary factor पर आते हैं, and it is the duration of sunlight. Duration of sunlight received. So for how much duration the sunlight is received. ठीक है? So if you look into this diagram which I have drawn of equinoxes and solstices, one thing you can understand, when there is solstice, can I say the areas which are away from the equator, the days will become longer? The days will become longer for them. ठीक है? You know that in the poles, the daytime is for 6 months. ठीक है? Which is also the summer of the poles. There is no night time during that period. So what happens? Duration of the sunlight is at equator. What we find at the equator, throughout the year we receive 12 hours of sunlight. ठीक है? Throughout the year, on an average, you receive 12 hours of sunlight. ठीक है? But what happens as we go from equator towards poles? ठीक है? There are two things. One is summer and the other one is winter. So in summer what happens? The duration keeps on increasing. ठीक है? So it keeps on increasing, and at the poles it is 6 months of continuous sunlight. But when we are here in winters, it is decreasing. It is essentially decreasing, and here there is 0 hours at the pole. There is no sunlight available at the poles. ठीक है? I'll show you. Can you see? The latitudes are mentioned, and the longest days and night are mentioned. So at equator it is always 12 hours. But as the latitudes keeps on increasing, can you see that the length of the day, how it keeps on increasing? For example, can you see around 67-degree latitude it becomes 1 month. 90-degree it becomes 6 months. ठीक है? So duration of the sunlight is also very important factor. And this duration of the sunlight जो अभी हमने diagram बनाया, it also plays a role in determining this distribution of insolation. ठीक है? This is the distribution of insolation which is found. अब इसके बेसिस पर मैं एक एवरेज बेल्ट बना सकता हूं. ठीक है? एक एवरेज बेल्ट बना सकता हूं. Although this is a more realistic way of showing it, a more theoretical way can be, agar if suppose only there was primary factors which are affecting the distribution, then so there is 10 degree to 10 degree latitude. This belt is, या फिर मैं इसको 0 से बोलूं, 0 to 10, it is equatorial belt. ठीक है? इक्वेटोरियल बेल्ट. 0 से 30 के बीच में हम ट्रॉपिकल बेल्ट भी बोलते हैं. दैट मीन्स इक्वेटोरियल बेल्ट इज अ पार्ट ऑफ द ट्रॉपिकल बेल्ट. इट इज विद इन द ट्रॉपिक्स. सो 10 to 30 degree is essentially the tropical belt. On an average, 30 to 45 degree is the subtropical belt. If you have read G.C. Leong, it also write it as warm temperate. ठीक है? So it is also referred to as the warm temperate belt. Then 45 to 60 degree is the temperate belt. It is also referred to as the cool temperate belt. Cool temperate belt. ठीक है? Then 60 to almost 80 degree is subpolar belt. Then there is the polar belt. There is the polar belt. ठीक है? So these are the belts of, you can say, temperature and insolation which are found on the Earth's surface. So if you talk about equatorial belt, for all practical purposes, we can say that almost how much of the energy which is coming, it is received 100%, near 100%, we can say, of energy available, it is received at the equator. As you are going towards the tropics में, it is around 90% of the available insolation is received. ठीक है? So 90% of the available insolation is received. When you are going in subtropics, here it becomes 75% of the available insolation is received. As you go temperate, 60% of the available insolation is received. As you are going in subpolar, 40% of the available insolation is received. ठीक है? In polar belt, it is less than 40% of the available insolation. ठीक है? So thus, just what we have done, we have simplified it. A more realistic is this one. ठीक है? More near to reality. So this should have been the scenario of distribution of insulation if there was operation of only one category of factors, that is the primary factors. But we know that the reality is more complex. In the real world, there is also the secondary factors. So secondary factors या फिर जो हमने word use किया, modifying factors. Why? Because they will modify the ideal scenario. ठीक है? सो बुक से जो कॉपी करके मैंने बुकलेट दिखाई थी उसमें बहुत सारे फैक्टर्स लिखे हुए हैं. But again, many of the factors don't make sense because what they have done just to increase the number of points, बहुत से factors जो actually temperature को determine करते हैं, they have written it also as the factors determining insolation. There is a difference between insolation and there is difference between temperature. ठीक है? So if you talk about secondary or modifying factor, first very important factor is the transparency of the atmosphere. ट्रांसपेरेंसी ऑफ द एटमॉस्फेयर. ठीक है? अभी हम हीट बजट की बात करेंगे, उसमें हम देखेंगे कंसेप्ट ऑफ एल्बिडो. ठीक है? एंड इन द कंसेप्ट ऑफ एल्बिडो वी विल सी एल्बिडो इज एसेंशियली व्हाट? द एनर्जी व्हिच इज कमिंग फ्रॉम द सन व्हिच इज रिफ्लेक्टेड बैक without being used. We will see out of the albedo, if we assume that albedo is 30, out of that 20 units are lost just by clouds. That means they are reflected back by the clouds. ठीक है? So what is the most primary factor which determines the transparency of the atmosphere? It is the cloud cover. It is the cloud cover. ठीक है? इस बार क्लिम्स का पेपर देखा है? There was one question about high clouds and low clouds. ठीक है? So if you talk about, बाद में जब हम clouds पढ़ेंगे तो I'll explain you. Like we will see, higher clouds are thinner. ठीक है? So if they are thinner, that means more energy should be able to pass through them. Lower clouds are thicker. ठीक है? So वो फंडा लगा करके वो सॉल्व हो जाएगा. बट हियर क्लाउड कवर इन जनरल वी आर टॉकिंग अबाउट फर्स्ट. सो क्लाउड कवर, देन have we talked about the aerosols? Very clearly, the aerosols. They are another major factor which determine the transparency of the atmosphere. ठीक है? So very very important secondary or modifying factor is the transparency of atmosphere. Then second very important factor is the aspect. In fact, you write topography. Topography. ठीक है? सो टोपोग्राफी की बात करें टोपोग्राफी में दो बहुत महत्व इंपॉर्टेंट फैक्टर्स हैं. फर्स्ट इज द ऑल्टीट्यूड. ऑल्टीट्यूड, ठीक है. सो टेल मी, if suppose there is this scenario and suppose this is the limit of the atmosphere, ठीक है. So in which case the sun rays have to cross larger atmosphere, more thicker atmosphere where there is lower height, ठीक है. As we go upwards, what happens with the rarity of the atmosphere? It increases, it tends to become more and more rare, less dense. That means the insolation which would be received at higher places would be what? It would be greater because there will be less loss of the insolation taking place. So with height, what we can write? With height, the amount of insolation received increases. The amount of insolation received increases. As I said, why? Because the density of atmosphere decreases with altitude. Because the density of atmosphere decreases with altitude. So one important factor is the altitude. Second very important factor is the aspect of slope. Aspect of slope. So aspect का मतलब क्या है? Direction of the slope. Direction of the slope. So think about a situation where suppose this is your 23 and a half degree latitude. Half degree latitude. And there is a mountain which is located here. ठीक है. So इसको मैं क्रॉस सेक्शन से दिखाऊं. Suppose this is your equator. This is your 23 and a half degree latitude, and we are saying here this is the mountain which is located. ठीक है. So tell me, can I say in this is in northern hemisphere, suppose we are saying. So in this, can we say that the northern slopes of this mountain would never receive direct sunlight? The southern slopes of the mountain would be essentially receiving direct sunlight. Okay? So that is essentially what? Because of the slope, because of the direction of the slope. So this is what we call it as the aspect of the slope. Okay? So these are the two major modifying factors which modify the total amount of sunlight received. ठीक है. फॉर एग्जाम्पल, पहले का अगर मैं एक एग्जाम्पल दूं ऑल्टीट्यूड का, बाद में जब हम मॉनसून पढ़ेंगे, व्हेन वी विल टॉक अबाउट मॉनसून, वी विल सी दैट द तिब्बतन प्लेटू इज वेरी इंटेंसली हीटेड ड्यूरिंग द समर सीजन. ठीक है. इट इज सो इंटेंसली हीटेड that there is a very strong low pressure develops over the Tibetan plateau. This low pressure plays very determining role in the generation of the monsoon. So why it is so intensely heated? Because Tibetan plateau is a very high plateau. Itself, its height is, average height is 4,000 to 5,000 meters. Okay? So clearly this means it would be receiving more sunlight during the summer season. So it becomes intensely heated. And again, we will see the difference later on when we'll talk about vegetation. So we'll see the difference between the northern slopes of the Himalayas, the vegetation found along that, and the southern slopes of the Himalayas. There will be difference. Okay? So these are your secondary or modifying factors. So दो factors and transparency or topography. हाँ. मतलब आई डिडंट गेट योर क्वेश्चन, फर्स्ट पार्ट क्या बोला? देखो, डेफिनेटली थोड़ा काउंटर तो उसका फैक्टर तो का तो पड़ेगा ही, बट यू हैव टू अंडरस्टैंड दैट व्हेन वी आर टॉकिंग अबाउट फ्लैट सर्फेसेस, ठीक है, फ्लैट सर्फेसेस पे क्या होगा, मोर सनलाइट वुड बी रिसीव्ड। वो जो काउंटर का फैक्टर की बात कर रहे हो, इट विल बी मोर एप्लीकेबल टू द स्लोप्स विच आर मोर टिल्टेड। द फ्लैटर द surface, the more amount of sunlight would be received, the surface would become very hot and it would generate higher temperatures। ठीक है, डेफिनेटली जो रेयरिटी ऑफ द एटमॉस्फेयर है वो तो फर्क पड़ेगा ही पड़ेगा। ठीक है, तो उतना हॉट नहीं होगा जैसा कि हम डेजर्ट्स में और ट्रॉपिक्स में देखते हैं। ठीक है, बट स्टिल कंपैरेटिवली एक चीज याद रखना, एक्चुअली दिस शुड हैव बीन द फर्स्ट लॉ ऑफ क्लाइमेटोलॉजी। जो मैंने बताया था, इट इज हीटेड फ्रॉम बिलो, दैट शुड हैव बीन द सेकंड लॉ। सो व्हाट इज द फर्स्ट लॉ ऑफ क्लाइमेटोलॉजी? यू मस्ट अंडरस्टैंड वट एवर वी स्टडी इन क्लाइमेटोलॉजी इज रिलेटिव। ठीक है, जितनी भी हम मेजोरिटी ऑफ जो थिंग्स पढ़ रहे हैं, दे आर रिलेटिव। सो वी विल सी, प्रेशर में हम स्पेशली देखेंगे, वी आर सेइंग लो प्रेशर, हाई प्रेशर, दीज आर बेसिकली व्हाट, रिलेटिव टर्म्स। ठीक है, so many times when we are using these terms, it is intensely heated, it is in relation to the places which are located at the same latitude। ठीक है, okay, so these are the two factors, transparency of the atmosphere, topography। अब यहां पर मैं तुम लोगों को एक कंसेप्ट इंट्रोड्यूस करता हूं which has been used by UPSC in the question paper and we should be knowing। So it comes from climatology, we are using two words, zonal and meridional। zonal and meridional। ठीक है, so what is zonal? Zonal is something which is arranged in accordance with the latitudinal zones। latitudinal zones, ठीक है, for example, did we saw in our ideal distribution of insolation, was it zonal? Did we saw zones, equatorial zone, tropical zone, subtropical zone, temperate zone, subpolar and polar zone? So that is what we mean by zonal। So when the distribution is like this, we are calling it as the zonal। ठीक है, meridional is when it is the phenomena is arranged in accordance with the meridians। मेरिडियंस क्या होते हैं? longitudes। So that means more north south arrangement। Here it is more east west arrangement, here it is more north south arrangement। So that is meridional। ठीक है, नाउ अगर हमें जो सेकेंडरी फैक्टर का इन्फ्लुएंस डायग्राम से दिखाना है, ठीक है, सो वी विल फाइंड दैट आउट ऑफ दीज टू फैक्टर्स, ट्रांसपेरेंसी ऑफ द एटमॉस्फेयर और टोपोग्राफी, इसमें से कौन सा ज्यादा जोनल होगा? This will have more zonal impact। Why? Because here the primary factor is the cloud cover। Distribution of clouds is found to be more zonal in nature। ठीक है, फॉर एग्जाम्पल बाद में देखेंगे कि सबसे ज्यादा जो प्राइमरी जोन ऑफ क्लाउडीनेस कहां पर मिलता है, बाद में देखेंगे, इट इज नॉट इक्वेटोरियल, इट इज द टेम्परेट बेल्ट। ठीक है, because in temperate belt there is a different type of clouds, the stratus clouds are found which cover more of the sky। ठीक है, इक्वेटोरियल बेल्ट में वर्टिकल डेवलपमेंट क्लाउड्स दैट इज द क्यूमुलोनिम्बस क्लाउड्स आर फाउंड. ठीक है. So secondary belt is the equatorial belt. So very clearly cloudiness is something which can be actually depicted on the map, which will be a determining factor. If you on the other hand talk about topography, can I say it is very random? Distribution of topography is very random. It is non-zonal in nature. It is non-zonal in nature. So अगर मुझे एग्जाम में दिखाना है डायग्राम के थ्रू, I won't be able to show the impact of topography. ठीक है, मैप में I won't be able to show, but can I show the case of cloud cover? Obviously I would be able to show. ठीक है, एक कॉम्प्लेक्स डायग्राम दिखाता हूं, however we can simplify it. ओके, इसमें नहीं है, मैं बना देता हूं. ठीक है. So suppose this is the world. Now ideally हमें सबसे ज्यादा कहां पर मिलना चाहिए इंसुलेशन? Should it be the equator? It should be the equator, but we will see that it is not the equator. ठीक है. Where we will be finding that the highest insolation would be found, it would be tropics and subtropics. More specifically, which areas of high insolation we will be finding? It would be essentially the tropical subtropical deserts, which are characterized by the lowest amount of cloudiness. ठीक है. So if you talk about, can I say this will be one area of high cloudiness? ठीक है. So sorry, low cloudiness. So यहाँ पर insolation received, we will see that इसमें जो बढ़ के हो जाता है 240, around 240 watts per meter square per year तक पहुंच जाता है. तो it is quite high. ठीक है. Then if you talk about another area where it is high is here, it is around 220 के आसपास पहुंच जाता है. Another area, tell me, should it be this place? Much of Australia is what? It is a desert. So again it will be around 220. यहाँ पर भी होता है. Another area where you will be finding is this area 220 like this. ठीक है. Another area which you will be finding is a small area here. So these are the areas which are receiving highest insolation. ठीक है. अब अगर बात करें, इसको मैंने थोड़ा सा बड़ा बना दिया है, जस्ट 1 मिनट. So equatorial belts are the areas where how much of insolation is received? Medium or less than, secondary terms mein. So if you talk about here, it is around, this is the area where you receive 180 watts per meter square per year. So similarly, this will be the area you will receive 180 watts per meter square per year. And third area कहां पर मिलेगा ऐसा? This will be the area where you will be finding the 180 watts per meter square per year. ठीक है? So this is the condition of the insulation distribution we will be finding. ठीक है? So tell me. So एक तो ये zone हो गए, and if you talk about, as I am going from here to here, should it be increasing? पहले increase करेगा और फिर जब मैं इधर से इधर जाऊंगा, what will happen? It should be decreasing. ठीक है? So this is the distribution where the lowest we are finding. The lowest zones are here. These are the lowest belt of insulation. और इसमें भी जो lowest areas होंगे कौन से होंगे? This and this. These will be the areas where you will receive lowest. ठीक है? So इस तरह से I can do what? I can make some circles and show which will be the high areas of insulation, which will be the low areas of insulation. ठीक है? कल मैं एक पेज दे दूंगा जिसमें वो एक्चुअली कॉम्प्लेक्स डायग्राम है, विच आई वांटेड टू शो, अभी इसमें नहीं था. यू विल सी दैट इट इज वेरी कॉम्प्लेक्स, और एग्जाम में उतनी कॉम्प्लेक्सिटी रेप्लिकेट नहीं हो सकती. ठीक है? सो व्हाट वी ट्राई टू डू, वी ऑलवेज ट्राई टू सिंप्लीफाई इट so that we'll remember those things which we can actually reproduce in the examination. जो reproduce नहीं हो सकता है उसको पढ़ने से कोई फायदा है नहीं. ठीक है? तो इस तरह से हम reproduce कर सकते हैं. ये जो मैंने ग्रीन लाइन बनाई है इसको छोड़ सकते हो अगर चाहो तो. ठीक है? या फिर मैं इसमें क्लासिफाई कर सकता हूं इसको, और सिंप्लीफाई करने का तरीका, वेरी हाई इंसुलेशन रिसीव्ड, हाई इंसुलेशन रिसीव्ड. ठीक है? मीडियम एंड लो. ठीक है? इस तरह से आई कैन क्लासिफाई इट. सो वेरी हाई हमने कहां पर देखा? इट इज द ट्रॉपिकल, सब ट्रॉपिकल डेजर्ट्स में, डेजर्ट एरियाज. सो यू कैन इवन शेड, मैप को शेड कर सकते हो जोन्स में. हाई एरियाज आर द ट्रॉपिकल रेन फॉरेस्ट. These are the tropical rainforest areas. If you talk about the medium zones, will be the temperate, and the low zones are polar, subpolar. Low zones are the polar, subpolar zones. Okay, so this is the way. If you talk about, there is distribution of insolation found on the surface of the earth. So can you see there is complexity in the distribution of insolation? ठीक है? It is not as simple as we actually made our ideal case diagram. ठीक है? So this was a some kind of ideal builds, but they don't exist in reality. यहां पर हमने अभी केवल एक फैक्टर लिया है, that is cloudiness, not even the full transparency of the atmosphere. Can I say if I also take into account the aerosols, will it become more complicated? Definitely it will become much more complicated. For example, बाद में जब हम अर्बन क्लाइमेट्स पढ़ेंगे तो वी विल सी दैट इन द सिटीज देयर इज मोर पीएम पार्टिकल्स इंट्रोड्यूस्ड बाय द ह्यूमन बीइंग्स. ठीक है? सो दिस पर्टिकुलेट मैटर व्हिच हैज बीन इंट्रोड्यूस्ड, व्हाट इट हैज डन, it has reduced the total amount of sunlight which is received on the surface of the cities. On an average, the scientists calculate the reduction is somewhere around 15%. ठीक है? So actually 15% कम sunlight receive हो रहा है. बाद में देखेंगे because of however more greenhouse gases, actually the heating effect is more. So देखेंगे कि there is a phenomena of heat island created in the cities. But when it comes to the actual sunlight received, it has declined in the city environments, the city climates. So that is the insolation, distribution of insolation. और ये बहुत इंपॉर्टेंट है समझना. तो यहां पर हमने दो तीन बातें देखी. ऑल्दो आइडियल केस में क्या होना चाहिए था, देयर शुड बी दिस दिस शुड बी वेरी हाई. ठीक है, दिस शुड हैव बीन द वेरी हाई एंड दिस शुड हैव बीन द हाई. But because of the transparency factor, what we find, it is getting reversed. ठीक है, उसके बाहर there is no change. Then moving on, next topic पर आते हैं, heat budget. Heat budget of the atmosphere. So I'll give an introduction to heat budget because we are about to finish the time and we'll complete this tomorrow. देखो, हीट बजट, सबसे पहले हमें ये समझना होगा, व्हाट डू यू अंडरस्टैंड बाय द टर्म बजट. बजट क्या है? Budget is simply a term which shows, other word I can use is balance or equilibrium. ठीक है, बैलेंस और द इक्विलिब्रियम. ठीक है. So when we are using the term heat budget here means there is equilibrium or balance between the total amount of energy entering the earth system and leaving the earth system. ठीक है. So there is budget or balance between the total amount of radiations received and the outgoing radiations from the earth atmosphere system. So that is what we essentially mean by the term heat budget or balance. ठीक है. Now number of things we will see that heat budget, एक तो simplified तरीके से हम पढ़ते हैं, it becomes complicated however in reality. ठीक है. So heat budget जो हमारे बुक्स में मोस्टली लिखा हुआ है, the it is written just in one sense and that is in the sense of time, temporal sense. Geography में याद रखना, geography we always see pattern in two terms, temporal and spatial. ठीक है. So geography में हमेशा temporal sense होता है and spatial sense होता है. So हम देखेंगे heat budget जब हम पढ़ेंगे तो we will talk about the heat budget from temporal point of view. ठीक है. So temporal point of view में you must have seen this heat budget in the books where they will talk about the total outgoing energy and the incoming energy from the sun. ठीक है. So इसमें जब हम temporal sense में पढ़ेंगे तो we will see number of components. Insolation is one component of the heat budget. Albedo is another component of the heat budget. Residence time of energy is another component of the heat budget and the terrestrial radiations are the other component of the heat budget. ठीक है. And we will see कि कैसे there is balance between the incoming and outgoing. But when we are studying, do you understand, it is more in time sense, in sense of time. There is maintenance of heat budget even in space. The heat budget will be working differently in different parts of the earth. कल भी मैंने इसको समझाने की कोशिश की थी. If you remember, there is a spatial aspect of the heat budget. So if you look into this, is the अभी क्या हमने देखा, this is the way in which energy is received at the lower latitudes. Is it higher? As you go towards poles, it declines. यही देखा था अभी हमने. ठीक है. But when we actually calculate the outgoing energy, we find that it is something like this. ठीक है. सभी जगह से more or less the terrestrial radiations going, they are more or less same. ठीक है. So इसका मतलब क्या हुआ, there is areas where there is deficit of energy and there is areas where there is surplus of energy. surplus of energy. Generally this surplus of energy किसके बीच में? Between 40 degree latitudes are the surplus. Outside this are the deficit zones. ठीक है, जैसा कल बताया था, if it continues like this, the areas between 40 degree latitude should be burning by now. They should progressively get hotter. On the other hand, outside the areas should be what? They should be freezing like hell. They should progressively get cooler. But we know the average temperatures of the latitudes are maintained. ठीक है, इसका मतलब है कि there is some mechanism to maintain the spatial heat budget, or in other words, can I use the term latitudinal heat budget? Latitudinal heat budget. ठीक है, और ये बहुत इंपॉर्टेंट कंसेप्ट है, बिकॉज वी विल सी दैट इट इज in to maintain this latitudinal heat budget, we find in the atmosphere various types of motions. ठीक है, various type of circulations. ठीक है, so you know primary circulation level पर we will be talking about the various forms of cells. Headley cell सुना होगा, Ferrel cell सुना होगा. So these are the primary circulation mechanisms. But देखेंगे these even below these macro level circulations or primary level circulations, there are other. So another form of macro level circulation is, we will later see, cyclones. They are below this level. ठीक है, उसके नीचे जाते हैं तो we find that there are even others like thunderstorms. These are another form of circulation mechanisms which objective is same, that is to maintain the latitudinal heat budget. ठीक है, उससे नीचे जाएंगे तो we'll find another like the local winds. So again they are basically what? Their objective is also the same, to maintain the latitudinal heat budget or the spatial heat budget or the place related heat budget. You might have seen smaller whirlwinds also rising at places. So again it is what? Even lower level, micro level circulations can be present. So all these movements in the atmosphere, why they are taking place? Objective is essentially to maintain this spatial or the latitudinal heat budget. ठीक है, बात समझ में आई? So when there is एग्जाम में अगर स्पेसिफाई नहीं किया है क्वेश्चन, लाइक मैं एक क्वेश्चन एक्सपेक्ट करता हूं इन फ्यूचर इन द एग्जामिनेशन कैन बी आस्क्ड, हाउ ग्लोबल वार्मिंग विल इंपैक्ट द हीट बजट. ठीक है, अब आप उसमें यू आर जस्ट राइटिंग द टेम्पोरल एस्पेक्ट ऑफ द हीट बजट and you are not mentioning the spatial aspect of the heat budget, you will be getting lesser marks. ठीक है, so that is what you have to understand. Heat budget should be seen in both temporal and spatial sense. So we'll stop for today. We'll meet tomorrow. Goodbye. Take care.